when there is an equality in the constraint, we come across something called as an unsymmetric form. When there is only inequality, then it leads to symmetric form. So now look at the first example here. Look at this. Subject to Ax equal to B. Since it is given as subject to Ax equal to B, what happens? Corresponding to this equal to, when I write my dual, I have minimized W equal to B, capital T denotes transpose. This is nothing but B transpose Y subject to, this is the same as A transpose Y greater than or equal to C transpose. So what happens? The equal to there becomes greater than or equal to here when you take minimization. And the one more change that occurs is the variables here are restricted. That is, the xi's are all greater than or equal to 0. In the dual, the variables are unrestricted. So this is our main. Then, suppose it's a minimization problem, the dual becomes maximized. So this is the same as our W equal to B transpose Y, and this is the same as subject to the conditions A transpose Y is less than or equal to C transpose. Okay, so whenever you have an equality, the variables will become unrestricted in the dual, and the equality will become either less than equality or greater than equality depending upon whether it is maximization or minimization. Okay, so that's what is written here. If the kth constraint of the primal problem is an equality, then the corresponding dual variable yk is unrestricted in sign and vice versa. If any variable of the primal problem is unrestricted, the corresponding constraint in the dual problem will be an equality and vice versa. So we'll take a small sum and we'll try to write the dual of that problem. So right now, write the dual of the LPP. Write the dual of the LPP. How to write the dual? Write the dual of the LPP. Minimize Z equal to, we have x2 plus 3x3, x2 plus 3x3, subject to the conditions, 2x1 plus x2 less than equal to 3, x1 plus 2x2 plus 6x3 greater than or equal to 5, and the third constraint minus x1 plus x2 plus x3, this value is equal to 3 and all my xi's are greater than equal to 0. Okay, so we want to write the dual of this particular problem. We will write the dual in the right hand side. Okay, so now you have to take down. What we have to take down? First, we have to identify that it is unsymmetric. Why? Because there is an equality constraint. So write down. The third constraint, if I am going fast, please stop me. Okay. The third constraint is an equality constraint. The third constraint is an equality constraint. Therefore, it is unsymmetric. Therefore, it is unsymmetric. Also, since the third constraint in the primal problem is an equality, the corresponding third dual variable, the corresponding third dual variable y3 is unrestricted in sign. The corresponding, I am repeating ma, since the primal problem, the third constraint in the primal problem is an equality, the corresponding third dual variable y3 is unrestricted in sign. Variable y3 is unrestricted in sign. So what will be our solution? Minimization will become what? What will happen? Maximization. So this would be maximize W equal to whatever is there in the right hand side. That is this 3, 5, this 3, 5 and 3. This will now becomes your CB. So I will have 3y1 plus I will have 5y2 plus 3y3. This is my objective function. Subject to what will be the constraint? I have to go for the first one. I have 2x1, so 2y1 plus corresponding to x1 in the second constraint I will have y2, then x1 in the third constraint is minus, so minus y3. I have maximized, so it is less than or equal to what do I have? I don't have any x1 in the objective function, so it is less than equal to 0. Then I have to take coefficients of x2. So it is first constraint is 1. So y1. Second constraint is 2x2. So plus 2y2. The third constraint is x2. So plus y3. Now what I should have is less than equal to coefficient of x2 in the objective function here value is 1. Then come for x3. First constraint no x3. So I will have 0 by 1 plus in the second constraint I have 6y2. Yes. Plus in the third constraint I have a y3 which is less than or equal to 3. Now third constraint is equality constraint. So I will have y3 is unrestricted. I will have y3 is unrestricted and y1 comma y2 are greater than equal to 0. So this will be your dual. Am I correct or am I wrong? Am I correct or am I wrong? Everything is correct? Ah, it is not second equation greater than equal to, sir. It is the first equation. We are talking about minimize z. Since it is minimize z, what I should do? I should take this equation and multiply by -1. Okay, so leave this problem. In this problem alone, you make this as greater than or equal to 3, then this problem is correct. It's not less than equal to, it's greater than equal to. So now this problem is correct. We know one problem with alternating signs also. Okay. Minimize, everything should be greater than equal to. Maximize, everything should be less than equal to. Okay. That is our standard form now from which we will proceed. So make this change in the question. Here it's greater than equal to, then this is the solution. Okay, once you finish, you please tell me. Can I go to the next problem? Yes. Write the dual of the primal. Right? We've done a minimization, we'll do a maximization. Write the dual of the primal. Maximize z. Okay, maximize z is equal to, you will have 6x1 plus 6x2 plus x3 plus 7x4 plus 7x4 plus 5x5 subject to the condition 3x1 plus 7x2 plus 8x3 plus 5x4 plus x5 equal to 2. Okay, equal to 2. Then 2x1 plus x2 plus 3x4 plus 9x5 equal to 6. So we need to write the dual of this problem. Now everything is given as equality. So write down here, x1, x2, x3, x4 greater than equal to 0 and x5 is unrestricted. X5 is unrestricted. So this is what is given to us. Okay. X5 is unrestricted. Now with this we have to frame the dual. So write down the primal contains two constraints, 5 variables. Dual will contain how many variables? Yeah? Dual will contain two only, just the reverse. The dual will contain two variables and 5 constraints. Okay. Next, since all the constraints in the primal, since all the constraints in the primal are equality, all the constraints in the primal are equality, all the dual variables are unrestricted in sign. All the dual variables are unrestricted. Wherever you have equality, it is unrestricted. Here, everywhere it is only equality. So, all the variables are unrestricted in sign. Then, over. Can I go to next point? Okay. In the next point, write down x5 is unrestricted in the primal problem. X5 is unrestricted in the primal problem. It is given, no, X5 is unrestricted. X5 is unrestricted in the primal problem. Therefore, the fifth dual constraint is an equality. Therefore, the fifth dual constraint is an equality. So this problem is unique in many aspects for us. Now we will write the solution. Therefore, the dual is, how to write the dual? Yeah. Therefore, my dual is, it should become minimization. Minimize W equal to, what should I write? What should I write? 2y1 and 6y2. Just for distinguishing the variables, we are using yi's. Then what will be the constraints? Ah, 3y1 plus 2y2. I am going to need coefficient of x1 alone. So it is 3y1 plus 2y2. It is less than equal to or greater than equal to, or equal to, what I should write? Less than equal to. Ah, minimization, so it should be greater than or equal to. The coefficient of x1 in the cost functions here is 6. So 3y1 plus 2y2 is greater than or equal to 6. Then I will have 7y1 plus y2. I am writing for x2. So 7y1 plus y2. Coefficient of x2 in the objective function is 6. So again greater than equal to 6. Come for the third one. We have only 8x3. So I will have 8y1 is greater than or equal to x3 coefficient is 1. Then what will happen to my fourth constraint? 5x4, 3x4. So 5y1 plus 3y2. I am in x4. Coefficient of x4 is 7. So it is greater than or equal to 7. Then come to x5. Coefficient of x5 in the first constraint is 1. So 1 into y1. Coefficient of x5 in the second constraint is 9. So plus 9 into y2 is greater than equal to what, yeah? So people are following. It is equal to, because the fifth one is unrestricted. Here x5 is unrestricted. Therefore, the fifth constraint is equal to. So it is equal to what? Equal to 5, because you are talking about x5. Any doubt for anybody? You are able to follow? Also, what will you have? Y1 and y2, because it is equality, they are unrestricted. They are unrestricted. So this is the only problem where we have used all the fact. Maximization becomes minimization, minimization becomes maximization. The number of variables there become the number of constraints here. Number of constraints there become the number of variables. Then if a particular variable is unrestricted, the corresponding constraint becomes an equality. So all the changes that are required for writing dual is incorporated in this one single example. Okay. So everybody is now in a position to write the dual of a given problem. If I give you the primal problem, is it possible for everybody? Yes, is it possible for everybody to write the dual problem if I give you the primal problem? Uh, So now we'll do one small problem. Write down the dual of the LPP and solve it. Write down the dual of the LPP and solve it. Maximize Z equal to, maximize Z equal to, we will have 4x1 plus 2x2, 4x1 plus 2x2 subject to minus x1 minus x2 minus x1 minus x2 less than equal to minus 3 minus x1 plus x2 minus x1 plus x2 greater than equal to minus 2, greater than or equal to minus 2, x1 comma x2 greater than equal to 0, x1 comma x2 greater than or equal to 0. Okay, write down the dual of the following LPP and solve it. Also write down the solution of the primal. Also write down the solution of the primal. Now look at this here. They are given maximization. What is the second inequality? The second inequality is of the form greater than or equal to. So we have to rewrite it. Write down. Solution. Multiply the second constraint. Multiply the second constraint of the given primal by -1. Multiply the second constraint of the given primal by -1. Okay. So what will happen? Minus x1 will become plus x1. This would become minus x2 is greater than or equal to 2. Okay. Yes, it will become less than or equal to 2. This will become minus, when you multiply, this would become less than or equal to 2. So now this is of the required format. We have got the maximization problem the way we need it. So the dual is, so your dual is, somebody should read out the dual for me. What will be the dual? Yes, minimize W equal to, yes, minus 3y1 plus 2y2. Yes, subject to minus, yes, minus y1 plus y2 greater than or equal to 4. Then, what will be the next one? Uh, Greater than or equal to, then all yi is greater than equal to 0. All yi greater than or equal to 0. Now I need to solve this. I am going to use simplex method to solve this. So how can I solve this using simplex method? Yes, how can I solve this using simplex method? My question is minimize w. I have greater than or equal to. Since I have greater than or equal to, what should I add? Slack or surplus? What variable should I add? Yes. Yes, now add surplus variables, add surplus variables S1 and S2, add surplus variables S1 and S2, and artificial variable and artificial variable R1 and R2, R1 and R2 with cost. What cost here? With cost. What will be our cost for this? Plus m or minus m? We are doing what problem? Minimization problem. Yes, it is plus m. It is plus. But how will I rewrite my function? Yesterday only I told you I will never keep my function as minimize w. I will say this is equivalent to, I will have maximize z star, that is maximize, minimize z is minus max minus z. So this is maximize z star equal to 3y1 minus 2y2. So here I can take the cost to be minus m, because I'll be rewriting my objective function as a maximization function. So once I do this, let us check what will happen here. My problem will now become maximize. I will have z star equal to, what is this? Minus 3y1 plus 2y2. I will have minus 3y1 plus 2y2 plus 0s1 plus 0s2 minus m into r1 minus m into r2, and when I do this, I will have my constraints as minus y1, I will have plus y2, minus y1 plus y2, then I will have a minus s1 plus r1, value is equal to, what is this value that I will have? 4. And what is the second constraint I will have? Minus y1 minus y2. I will have minus y1 minus y2. Minus of this value. Yes, what is this value? I have minus 3y1 plus 2y2. Minimization of this is max of the negative. So this would be minus of minus 3y1 plus 3y1 plus 2y2 will become minus 2y2. Yes. What did I write? This should be 3y1. Okay, I have to look at some. Yes. 3y1 minus 2y2. Now it is alright. 3y1 minus 2y2 plus 0s1 plus 0s2 minus mr1 minus mr2. Subject to our constraints, we are having minus y1 minus y2. Then I will have a minus s2 plus r2. This value is equal to, what does the slide say? 2 for all my yi, comma si, comma ri greater than equal to 0. So let us now construct our table. What will be this table for us? Can anybody give me the heading? Hmm, hmm. C3, xp, I will have y1, y2, s1, s2, r1, r2. I'll have a theta. Now what I should write on top of the table? Cost from the objective function. So this y1 will be 3, y2 will be minus 2. Corresponding to s1 from the objective function, it is 0, 0. Then I will have minus m, again minus m. Now what are the bases? Basis elements are 1, 0, 0, 1. The vector corresponding to 1, 0, 0, 1 is given by our artificial variables. Therefore, it is R1, R2. What is the cost? Cost is minus m. Again, it is minus m. What is xb value, ma? What is xb value? 4 and 2. Right hand side of the inequality or equation, you have to write right hand side of equation rather. So it is 4 and 2. So my y1 will be minus 1, 1, minus 1, 0, 1, 0. The second row I will have minus 1, minus 1, minus 1. No, I won't have a minus 1 here. I will have S1 is 0, S2 is minus 1, R1 0, R2 is 1. How you write your YB is, after filling this also you can write. If you fill all the entries from XB to R1, R2, take the variable corresponding to your basis vector. What is the basis vector? E1, E2, etc. So R1 and R2. Like that also you can choose. Now we have to compute Zj minus Cj. How are we going to find out Zj minus Cj? Before finding Zj minus Cj, please remember the formula that you have for finding Zj minus Cj. What I should do is, I will have Cb into this y1 column minus the cost on the top, minus m into minus 1, m, minus m into minus 1, add both 2m. So I will have 2m minus 3. Come for the second y2 column, minus m into 1 minus m, minus m into minus 1 is plus m, Minus m plus m is 0. 0 minus of minus 2, 2. From where I got that minus 2? From the top. Okay, from here only I am having 0 minus of minus 2 is 2. Then come for S1 column. Minus m into minus 1. Value is m. Then come for S2 column. The first row becomes 0. Second row will be minus m into minus 1. Value becomes m. Then come for R1 column. In R1 column you have minus m into 1 is minus m. On the top you have minus m. So minus m minus of minus m, value becomes 0. Similarly for the last column, first entry is 0 into minus m, 0, plus 1 into minus m is minus m plus m, value becomes 0. Now look at this here. Here itself all our Zj minus Cj are greater than 0 because m is very large. So all Zj minus Cj are greater than equal to 0. What should I say? What should I say? Till here it is clear for everybody. Now everybody understood how to calculate our Zj minus Cj. Hmm. So now what comment I should give? I have all Zj minus Cj greater than equal to 0, comma, what happens? My artificial variables are there in the basis at non-zero level. R1, R2 is present in basis. It is present in basis. In basis it is present means what? It is there in our YB. Since it's there in YB, we say it is present in basis in non-zero level. In non-zero level, therefore, what can I say? There is no basic feasible solution. Therefore, therefore the dual has no, what should I write? It has no optimum basic feasible solution. Therefore, there exists no optimum basic feasible solution. First of all, solution itself is not there. Then where to read the solution of the primal problem? So this problem is such that you don't have any basic feasible solution. Okay. We'll do one more sum and I'll teach you how to read the solution. I will be giving you only the final iteration and the first iteration. In between iteration, you should do as homework or you should do when I take attendance. Okay. So as far as this sum is concerned, anybody has any doubt? Hmm. Zj minus Cj for R1 and R2. Okay. Right. Now please look here. Whatever I write in blue is the calculation for Zj minus Cj. Okay. So this is for our reference. What I write in blue. Okay. You want Zj minus Cj. I want R1 and R2. Come to the R1 column. As I say, you write down. Come to the R1 column. Multiply CBR1 minus the cost. Now, what is the CBR1? Look at this here. This is my R1 column and this is my CB column. How I should multiply is this 1, I should multiply with this minus m. So 1 into minus m plus I should take this 0. Correspondingly, this minus m plus 0 into minus m minus this cost on the top minus of minus m. Now what happens here? Minus m plus m value becomes 0. Okay, no problem. Everybody set your messages here. Then, right. So take down the sum. We will write the dual. I will go to the final iteration, and then I will discuss the solution with you. The intermediate two iterations you have to do, and you will show it to me as homework in the GCR. Right. Use duality to solve the following LPP. Use duality to solve the following LPP. Okay. So our question is a minimization question. Minimize z is equal to 2x1 plus 2x2, 2x1 plus 2x2 subject to 2x1 plus 4x2 is greater than equal to 1 minus x1 minus x1 minus 2x2 is less than equal to minus 1 2x1 plus x2 is greater than or equal to 1 and x1 comma x2 is greater than equal to 0. Now can anybody give me the dual? This is your primer. So what should I do first? I have greater than equal to, I have less than equal to. How should my inequality look? I want the inequality to be greater than equal to. So what I should do? I can multiply the second constraint by minus 1. So what happens? I will have x1 plus 2x2 is greater than or equal to 1. So the given problem is right now fixed for me. Now I have to write the dual for this problem. So how to write my dual? Now how many constraints will be there in the dual? Yeah? How many constraints will be there in the dual? Only two? Yes, there will be only two. So what will be your dual problem? Your dual problem would be maximize W equal to, yes, can anybody tell me? Maximize W is equal to, yes, y1 plus y2 plus y3. There will be three variables. See, the number of constraints, one minute. The number of constraints in the primal is the number of variable in the dual. So that we should remember. So it is y1 plus y2 plus y3 subject to, what will I have? 2y1 plus y2 plus 2y3. I will have less than or equal to, what is this? 2. Then I will have 4y1 plus 2y2 plus y3 is again less than or equal to 2. What happens to my yi? All my yi are greater than or equal to 0. So this is our required dual problem. Am I correct? Any other changes should I make? Any other changes should I make? Now tell me, should I add slack variable or surplus variable? Yes, I should add slack variable. So write down. Adding slack variable with cost 0. Adding slack variable with cost 0. What will I get here? I will have maximize z is equal to, can anybody call out? y1 plus y2 plus y3. y1 plus y2 plus y3 plus 0s1 plus 2y1 plus y2. If I miss out on anything, you please tell me. 2y1 plus y2 plus 2y3 plus s1. We are adding the first slack equal to 2. Equal to 2. Then 4y1 plus 2y2. 4y1 plus 2y2 plus y3 plus s2. This value, what will this be? This is also equal to 2. All my yi's, comma si's are all greater than or equal to 0. Now, what should I do? I will have CB, YB, XB. I will have Y1, Y2, Y3, S1, S2, and I will have a theta. Come on, start solving. Right. So what will I have on the top? I will have y1 coefficient is 1. I have to look into the objective function to write the top entries. So 1, 1, 1. Coefficient of y1, y2, y3. S1 and S2, 0. Then here I will have 2. Here also I will have 2. Am I correct or am I wrong? Huh? Yes, S1, S2 will be there in place of YB. What will be there? Where will the 2 be? Under XB. Then what happens? My y1 becomes 2, 4, 1, 2. Am I right? 2, 1, 1, 0, 0, 1. The variable corresponding to 1, 0 should come here. That is S1. The variable corresponding to 0, 1 in the second place. That is S2. What is the cost? Cost is, what is the cost? For S1 and S2, value is 0 from the objective function. Therefore, it is 0. See, S1 cost 0, S2 cost is 0. So, here in both the places, it is 0. Now, start your solution. I want Zj minus Cj. Since it is 0 here, every column when you multiply with 0, it will become 0 minus 1. Here 1 into 0 plus 2 into 0 minus 1. 2 into 0 plus 1 into 0 minus 1. Here again 0, 0. Check if you are getting this only. Whichever minus 1 you want, you can choose. It is your choice. Which you want to choose? Yes, which you want to choose? You want to choose the first one. Okay. One of you choose second one also, yeah, you will find that the answer doesn't change finally. Right. If I choose the first one, this becomes my key column. I want to find theta value. What is theta now? Here it is 2 by 2. Value is 1. Here it is 2 by 4. Value is half. That is, you should take this xb by yi. Theta is xb by yi. So this is the value. The smallest one leaves. So this becomes my key row. Check here. Go for the next iteration. You will have S2 leaves and Y1 enters. So you will have S1 Y1. I will have S1 Y1. I need Zj minus Cj. I'm going to have my CB, YB, XB, all these values. I have my S1 and Y1. So I must go for CB. I will have an YB. I will have XB. I'm having Y1. What else I have? Y1, Y2, Y3. I will have Y2, Y3, S1, S2, theta. Here everywhere value is 1 and here the value is 0. Now let us compute this value. What is the cost of y1? It is 1 and here it is 0. Now what I should do here, every element of the key row should be divided by 4. So 2 by 4 will be half. Half, 1 by 4. So I will have half, 1, half. I will have a 1 by 4 and then 0 and 1 by 4. Now what enters is y1. So the other entry here will become 0. Now try to fill all the entries. You will get your entries to be 2 minus, come over here, 2 minus 2 into 2 by 4. So 2 minus 4 by 4 is 1. So over here you will have the entry as 1. Come over here, 1 minus 2 into 2. 4 by 4 is 1. Entry becomes 0. Then come over here, 2 minus 1 into 2 is 2 by 4 is half. 2 minus half is 3 by 2. So here entry becomes 3 by 2. For your S1, it is 1 and S2, it is minus half. So here it is 1 and here it is minus half. Now find out Zj minus Cj. Here 1 minus 1 is 0. 0 into 0 is 0. Plus 1 into half is half. Half minus 1 is minus half. CB, YB minus the cost on the top. So 0 into 3 by 2 plus 1 into 1 by 4. 1 by 4 minus 1 minus 3 by 4. Then again here value becomes 0. Here value becomes 1. What should enter here? Half or 3 by 4? The most negative term enters. What should enter? Minus 3 by 4 enters. Now xp by yi, 1 by 3 by 2 is 2 by 3. Then half by 1 by 4. Half by 1 by 4 is 4 by 2. Value is 2. So the first row leaves. When the first row leaves, y3 enters. So you have y3, y1. The values here are 1, 1. Now calculate what happens to my xb. What happens to my xb? I have this to be my key row. Okay, this is to be my key row. So I should divide throughout by 3 by 2. So it is 2 by 3, 0, 0, 1, 0, 2 by 3 minus 1 by 3. Again evaluate half minus 1 by 4. Check half minus this half minus 1 into 1 by 4. 1 into 1 by 4 by 3 by 2. So 1 by 4 means half minus 1 by 6. So 3 minus 1 by 6, 2 by 6, 1 by 3. Check here, I may be wrong. Here it will be 1, here it will be half. Then here I have to come 0 minus 1 by 4 into 2 by 3. So here it will be minus 1 by 6. Then come for the last term, it is 1 by 4 minus half into 1 by 4 divided by 3 by 2. What is this? 1 by 4 plus minus of minus. It is 1 by 2, 1 by 2 will get cancelled. So 1 divided by 12. So it is 4 by 12. 4 by 12 is 1 by 3. Check here. Check. Now find Zj minus Cj. Okay. Now find your Zj minus Cj. Now, again, we have to take attendance. I have to leave. You have to go 2 more iterations like this. Yes, yes, no problem. I'll take attendance and leave. What you have to do is you have to go 2 more iterations. When you come for your class tomorrow, finish. In the this is the first iteration, 0, 1. Then 2 more, second and third. Finish the third iteration and come. I will tell you how to read the solution. With that, this procedure will get over. Okay.